Hello everybody, I'd like to welcome you to this video titled Common Factors and Multiples. You'll need to get out your math book and turn to page 11, get out your math journal and a pencil. So there are two learning objectives for this lesson. So first of all, you want to be able to find common factors and the great common factor of two whole numbers. A lot of times we call this the GCF. All right, and also you want to find common multiples and the least common multiple of two whole numbers, or the LCM. So you want to find the GCF and also the LCM of two numbers for this lesson. So you can see on page 11 it's saying find the common factors of 12 and 30. So I know they show you a different way of doing this in the book, but another way you can do this is by using a table here. So we have 12. Okay, and what we think about is we have 1 and 12 as a factor. And then now the next number we want to think about is 2 and 6. 2 can go into 12 6 times. And then the next number would be 3 and 4. Now the key question is, how do I know when I've listed all my factors? Whenever there's not any other number between the left and the right side of the table, that means you've listed all your factors. So the factors are, for 12, we can see are 1, 2, 3, 4, 6, and 12. Those are the factors of 12. So let's take a look at 30. So the factors of 30. Make a table. I always start out 1 times 30 is 30. 2 times 15 is 30. 3 times 10 is 30. And then 5 times 6 is 30. How do I know I've listed all my factors? There's not any other number that would go into 30 between the 5 and the 6. So my factors of 30 would be 1, 2, 3, 5, 6, 10, 15, and 30. I'm kind of running out of room here. So we can see the common factors, as you can even see in your book. 1 and 1, 2 and 2, 3 and 3. So you can see 5 is not a common factor, 6 and 6, 10 is not, 15 is not, 30 is not, 4 and 12 are not. So we can see the common factors are 1, 2, 3, and 6. So that's how you find common factors of two whole numbers. And then if we're talking about greatest common factor, that's just the greatest of the common factors. So the GCF, and I'm kind of jumping ahead a little bit, we can see is the number 6, greatest common factor. And then I can see in your book, this is what it looks like, but I just showed you a different way to find common factors of those two different numbers. Now let's take a look at page 12. It's saying find the greatest common factor of two whole numbers. Okay, so you can see for number 1, it says find the greatest common factor of 45 and 75. Now I would like for you to write this in your book, just like I am on the paper. Write this in your math journal like I am right here in the video. Okay, so we're going to do this as a table, and I know it shows you a different way in the book, but we're going to do it as a table. So we have 45. So my first one is 1 and 45. And then now I do 3 and 15. And then 5 and 9. So my factors of 45 are 1, 3, 5, 9, 15, and 45. So what we'll do is we'll erase this a little bit here. I'm just going to write 45 down here and write my factors of 45. 1, 3, 5, 9, 15, and 45. If you need to pause the video, you can do that and write them in. Now I'm going to write 75 here. I'm going to give myself enough space. I'm going to write it as a table. 1 and 75. 3 and 25. 5 and 15. And those are my factors of 75. How do I know those are my factors of 75? There's not another factor, another number that would go into 75 that's between the 5 and the 15 there. So we write 75 here. We do 1, 3, 5, 15, 25, and then 75. Okay? So now that we have all our factors listed, we want to find the greatest common factor. So greatest means largest number, common in both lists. So we'll find the factors here. 1 and 1, 3 and 3, 5 and 5, 9, there's not a common factor, 15 there is, 45 there's not, and I can see the greatest common factor, GCF, is going to be 15. And I know this showed you a different way in the book, but that's another way that you can solve this type of problem as well. Now let's turn to page 15, and it says, use the greatest common factor with the distributive property. All right, so it says express 12 plus 20 as a product of the greatest common factor of the numbers and another sum. Okay, so the first thing you need to do is find the greatest common factors of the two numbers. Okay, and you can see with this, they showed you a different way to find the greatest common factor than I did, which is fine, but we can see that the greatest common factor of 12 and 20 would be 4. Okay, so now what we need to do, we need to think about how to write the sum a different way. Okay, so we know that 4 times 3 is 12. We also know that 4 times 5 is 20. Where am I getting my 4 from? Remember, that's my greatest common factor. Okay, so if I were to have 12 plus 20, that will also equal 4 times 3, which gives me 12, plus 4 times 5, which gives me 20. Now, using the distributive property, what would that look like? Would multiply my 4 times 3, which would give me 12, and also my 4 times 15, which would give me 20. So that's how we would use that using the distributive property. Now we're going to take a look at finding the least common multiple of two numbers. So we found the greatest common factor, and now it's the least common multiple. So what I like to do with the least common multiple, I like to list the first 5 multiples of both numbers. So what we have here, we have 8 and 12. So I'll do the first 5, 8, 16, 24, 32, and then 40. Okay, you always start out with the first number, with the number first. So you're skip counting by 8. Now I'm going to skip count by 12. Why 12? Because that's my number. 12, 24, up and right away. The first number that we come across is 24. So that would be the least common multiple of these two numbers. That means it's the smallest number that both numbers go into. Sometimes you want to take a look at if that smaller number can go into the larger number. And if that's the case, then the larger number would be the least common multiple. Okay, so that's a little tip. If you ever want to take a little shortcut, do that first. But list out the multiples. The first number that's in both columns would be the least common multiple. Now, if you ever find yourself listing 10,000 numbers and you think you're going to run out of paper, that means you probably might have done a calculation wrong, something like that. So just double check your work whenever that happens. So you can see on page 17, find the least common multiple of two whole numbers. So it's saying find the least common multiple of 6 and 9. So you can see you can list the different multiples of 6 this way, different multiples of 9 that way. So that's what we're talking about when you're listing the multiples of two numbers. So list the multiples of 6, multiples of 9. You can see this right in your book as well on page 17. And then we can see the common multiples of 6 and 9 are 18, 36, and 54. However, the least common multiple, or the LCM, would be 18. So again, list the multiples. Do not panic too much if you don't get the common multiple of the first 5. So list the multiples, and then from there, find the least common multiple. So the LCM of 6 and 9 would be 18. So going back to the think question on page 11, it says Miss Jones wants to use square patches to make a rectangular sail that measures 36 by 52 feet. She wants to use the fewest square patches without cutting any of them. What is the length of each side of a square patch? So we'll talk about this in class when we come to work on this lesson. This concludes the video on common factors and multiples. Please let me know if you have any questions about this concept, and I look forward to working on this concept with you in class.